Hey everybody, welcome back to the channel. Joe Lonsdale is one of the Palantir founders that doesn't get talked about that much because he doesn't really have an active role with the company anymore. He was one of the initial co-founders along with Stephen Cohen, Alex Karp, and Peter Thiel. Alex Karp is obviously the CEO. Peter Thiel is just like this big tech mogul. I found an interview, or not an interview, a keynote with Joe Lonsdale talking about Palantir back in 2017. This was before Palantir went public, so he couldn't say like that much. He kind of had to give some like more general descriptions. And this was a Q&A with him at the University of Waterloo, telling people how they can optimize for a career in technology. So it's about a 5-minute clip, really good stuff. I wanted to analyze it. I wanted to talk about how one of the founders of Palantir thinks about Palantir, and it should hopefully give us a little bit more insight into the data problem that Palantir is trying to solve from one of the original founders of Palantir. Let's get into it.
It's major industries. So even today, if you go into almost any government organization, any bank, any logistics company, any hospital, there's stuff there that's probably running from the 1970s or 80s that's kind of processing their inventory, processing their payroll, processing all sorts of basic processes and keeping track of stuff. And the reason it's there is it's worked really well for 50 years. But the problem is nowadays, as you all know, there's 1,000 times as much data. And your job running these industries is to use data to make better choices. And so the thing you start to learn about big industries pretty quickly, the more time you spend with them, is this like they're really broken compared to what they could be if they were using their data better. So in logistics, for example, there's millions, I don't know the stats for Canada, but around America, there's literally like millions of miles of like trucks driving in parallel that are both less than half full, where they could, where the similar place left from similar destination. It's obviously just that they didn't know how to coordinate, because that's a very hard data coordination problem. They may even be competitors, but even though they're competitors, if they had coordinated and used one truck, that would have actually saved everyone money and been good for the environment.
So real quick thing that he's talking about there, I thought this was a really, really interesting point. If you have two trucks coming from an apparel company that are competitors with each other, so let's call them like, I don't know, Walmart's apparel company versus Target's apparel company. Those trucks right now in this example are operating on the road and they're half full, which makes no sense because you're wasting a ton of gas because then you're gonna have to make two trips. And it's just not optimal because then you have to go back and forth and then you can't be as efficient as getting the stuff onto the shelves because like you have to go get the stuff that wasn't on the truck because it wasn't half full. So he's like, well, if you have two competitors, and you could take half of Walmart stuff, half of Target stuff, and put it in one truck, then you save the gas, right? So it's good for the environment, and it's more efficient for both supply chains, even though they're competitors. So it's a big data coordination problem, and a software like Palantir could help give the recommendation to Walmart saying, hey, your competitors have the same problem. Why don't you guys integrate and work together? It's not going to hurt any of your profits. It's actually going to increase your profits because things are going to get more efficient, but you need technology at its core to solve that type of data problem. So there's like this real world data application that can be applied to very specific scenarios to actually create results that are beneficial for companies in the real world.
And that's just like one, it's a silly data problem, but there's examples of this in every industry. Like when you're going to issue a mortgage, we actually could figure out, like one of our companies, Blend, this like the costs are actually like a fourth of what they were before, because you can bring all the data automatically together for the process of how you help the bank issue the mortgage and figure it all out. But there's literally probably about 200 industries right now where there's specific vertical platforms where there's problems around kind of using data to make that part of the industry work better. And so unlike the consumer wave, where there's only really kind of 20 or so really big consumer companies that came out of those 20 years, those are the really impactful ones. We think there's more like 200 companies coming out of this kind of smart enterprise wave to really fix things specifically in different industries. I was just at RubiCloud earlier today in Toronto, which really amazing team. I'm very bullish on a lot of people from Waterloo there, and doing something similar for back end of retail for the same things. How do you use all this data to run a retail store better? How can you be more like Amazon and learn from what they're doing? And there's all these challenges there. So that's one area that we're really excited about. It needs a lot of really great engineers. Probably still see a lot more companies being built there in the next few years. The other one I'd say is even more recent. So again, I think that the hardest question is like, what's possible now that wasn't even possible 3 years ago? And that's okay. Well, what is going on in the world that's new, just really, really recently? And our best answer to that we've been spending a lot of time on in the last few years, is that a lot of areas of biological science have become information problems.
So this is a really good thing he's going to talk about, right? But right before this, he talked about a supply chain logistics issue, which is a big data problem for a lot of companies because a lot of companies have supply chain data issues. But now he's about to talk about biotechnology, and biotechnology is drugs that could potentially save people's lives, right? So it's interesting to sort of figure out what he thinks about the data problem that exists there. Again, this was back in 2017.
And so obviously you guys have probably heard about CRISPR. Who knows what CRISPR is? I'm curious. Okay, so about a third of you or so. So as an example, CRISPR was a really big breakthrough. A friend of ours, Jennifer Doudna, is a scientist at Berkeley, and she was collaborating with Feng Zhang at the Broad Institute at MIT. and they're studying basically this new system that emerged from bacteria. So it turns out that bacteria and viruses have been at war for like 3 or 4 billion years. That's, for most of evolution, that's the only thing that's been around is bacteria and bacteriophages or viruses, and they're constantly trying to kill each other, and they're constantly evolving new ways of killing each other and new ways of stopping that from happening. And it turns out that one of the most important weapons bacteria developed is this part of their immune system that if a virus causes them trouble, they take something and they snip a piece of the virus's DNA, they put it in their own DNA, along with some messages next to it so they know what it is. And then when other viruses come in, they use that to create the RNA and to go search and look and say, oh, if it's the same one that causes me trouble, I know what it is, I know it's there, I know I can go after it and try to snip it or kill it or whatever. And so it turned out that in evolving this, they evolved like the most efficient way we've ever seen to very accurately write DNA. And so it turns out there's something called a Cas9 protein paired with an RNA, and it can very quickly search and find DNA and either cut it, insert it places, snip it, all sorts of different types of protein and things you could do there. And the reason this is really important is it's like a computer basically. It's like basically you can automatically with trillions of DNA somewhere very quickly scan and find the right one and do something to it. So it becomes this like all-purpose machine that works for plants and animals and everything. And so when you can really quickly and easily edit these things, then on top of that, as you guys know, the cost of reading DNA has just gone down dramatically to the point where it's very, very cheap now to, for example, we used to have 3,000 types of bacteria in our guts, and as your health changes, the bacteria that are present change. And now we have a company, I probably shouldn't say how much, but it's a very, very small amount of money where they can just measure exactly what all the bacteria are in your gut, exactly what's going on. And once you do that for 200,000 people, as they've done, they can say, oh, well, every time someone has Crohn's disease, it's like this pattern shows up. So like I say, this person has a 99% chance of Crohn's disease, or this person has a 99% chance of inflammatory bowel disease, or whatever else, right? So there's all this data available. So both with like the reading and the writing and experimentation and iterating and building things, it's all become a giant IT problem to map out. And it's not to say you don't need the scientists. You do. You need good biological scientists. But if they don't have really good engineers, then they're in big trouble. So there's a bunch of companies now growing fast in the microbiome, in iterative gene editing, experimentation, the infrastructure for gene editing that are all growing very fast, and mainly in Silicon Valley where we are, because it's the combination of the scientists and the IT. So anyway, that's a very exciting area. I could talk to you about that one all day, but we can always answer more questions if people are interested.
So that's Joe Lonsdale, co-founder of Palantir, talking about this back in 2017. I thought this was a really interesting insight because he's describing a data problem in two different subsets of sectors that exist in the economy. Number one is supply chain and logistics, so like silly data problem, right, with Walmart and Target example. And like that's a big data problem for those two companies, right, because if they can solve that problem, that's a lot of profits and revenues that they're going to be able to generate. But then you got this biomolecular DNA type of thing. CRISPR, it's interesting. Was CRISPR public in 2017? Because I know CRISPR is a hot stock right now. I think it's like $65, or am I wrong on that? CRISPR's at 66. It's been around for 5 years. At 2017, wow, it's $15. So that's what, a 3x, 4x, almost 5x, almost 4x return, since a little bit over 4x, 4.1x. Not bad. And in its highs, it got to 220. Well, that was January 2021. That was when everything was going crazy. So he was talking about CRISPR back in 2017. And yeah, the process he was describing about like pattern recognition within your DNA and being able to say, okay, we did this for 200,000 people. We know when someone has Crohn's disease. We know when someone has an inflamed gut. We know that these things are happening because of these other patterns, because we have technology that is able to analyze and synthesize. That's the key thing right there. Not just analyze, but synthesize hundreds and thousands and millions of data points to be able to come to a conclusion. And I like at the end what he says, which is that this is not to say that you're replacing scientists or you're replacing human beings. And CARP has been very, very big on that, if you know anything about Palantir, which is that they don't want to be a company that automates away jobs, right? That's not the goal. The goal is how can we make humans, especially non-technical humans that are working in these roles at companies, to better understand the data that they're working with, better understand how to interpret the data and make sense of the data and make more actionable decisions so that the data makes your life easier. So as scientists, it's just not valuable for a scientist to be there if they don't have the engineers to be able to make sense of the data. Now, the scientist is probably there from an expertise perspective to find the data and like find the pinpoints of the stuff, to ask the questions of why we're even looking at these certain things. But the engineers are then there to make sense of it. And I think that's a very symbiotic relationship between those two partners, which means that it's not automating away those jobs. It's not taking away those jobs. It's technology enhancing those jobs in a much more meaningful way. And I think that's sort of the macro level vision of Palantir writ large. So I thought this was really good clip by Joe Lonsdale. I'm going to try to dig up more and more Palantir founders talking about the company back before it was public and sort of giving their overview, giving their perspective. I think as an investor and a shareholder, when you're going deep into a company, when you have thousands and thousands of dollars in the company, you've got to understand the company inside and out, because there's going to be plenty of bearish articles. There's going to be plenty of things going back and forth, questioning your commitment to the company, questioning your commitment to your investment. And when you know what the founders thought about the company long before the company was recognized by the public as being that company, you can sit back and be like, yeah, I knew that was going to happen, which is what most of Tesla shareholders did, because they knew Elon's vision. They knew the macro level vision. They knew Wright's law was decreasing battery costs by double every single year. So when you know these types of things, then you're able to feel better at night with your investment. And it just gives you more perspective on the people that you're investing in, like Joe Lonsdale, who was a co-founder of Palantir. So yeah, those are my thoughts. Let me know what you guys thought about this in the comments. Looking forward to reading them. My name is Bit. I will see you guys in the next one.